Hello everyone, welcome back to the channel. This is the part 3 of the trigonometry series for class 10 from the textbook Concise Mathematics by Selina Publications. In this session, we will complete the questions from 31 to question number 48 of exercise 21A. In case you want to refer to the answers of question 1 to question 30 of exercise 21A, the links are getting displayed on the screen right now. Let's now begin with question number 31, where the left hand side is given as cot A minus cosec A whole square. Now we know that cot A can be written as cos A divided by sin A, and cosec A can be written as 1 upon sin A. Now we will take the LCM here, which will be equal to sin A, and the numerator here will become cos A minus 1 whole square. Now we can write the numerator and denominator as cos A minus 1 whole square, and the denominator will become sin square A. Now we know that sin square A is equal to 1 minus cos square A by the trigonometric identity that sin square A plus cos square A is equal to 1, and the numerator can be written as cos A minus 1 whole square. Now we will take out minus sign common from the denominator, and it will be of the form A square minus B square now. Now the denominator can be written as cos A plus 1 into cos A minus 1 by the formula, since A square minus B square is equal to A plus B into A minus B, and the numerator can be written as cos A minus 1 into cos A minus 1, since A minus B whole square is equal to A minus B into A minus B. Now we can cancel out cos A minus 1, cos A minus 1, and we can use the negative sign here in the denominator to reverse the signs in the numerator, which now can be written as 1 minus cos A divided by 1 plus cos A, and this is equal to the RHS, hence proved. The next question has the left hand side equal to cosec A minus 1 divided by cosec A plus 1. Here we will first convert it in the form of sign by writing cosec A as 1 divided by sin A, and in the denominator also we will write 1 divided by sin A plus 1. When you will take the LCM, this will become 1 minus sin A divided by sin A, and the denominator part will become sin A divided by 1 plus sin A. Sin A will get cancelled out, and we are left with 1 minus sin A divided by 1 plus sin A. Now we will multiply both the numerator and denominator by 1 plus sin A, because we need 1 plus sin A square in the denominator. So the numerator will become 1 minus sin square A. This is because A minus B into A plus B is equal to A square minus B square, and the denominator will become 1 plus sin A whole square. The numerator can be written as cos square A, and the denominator will become 1 plus sin A whole square. Here we have used the identity that sin square A plus cos square A is equal to 1. Therefore, 1 minus sin square A is equal to cos square A. Now we can take the square power outside the bracket. So this will become cos A divided by 1 plus sin A whole square, and which is equal to the right hand side, and hence proved. Let's now begin with question number 33, and the left hand side is equal to tan square A minus tan square B. Tan square A can be written as sin square A divided by cos square A, and tan square B can be written as sin square B divided by cos square B, since tan theta is equal to sin theta upon cos theta. Now we will take the LCM, which will be equal to cos square A into cos square B, and the numerator can be found out by cross multiplication here. So this will be equal to sin square A into cos square B minus sin square B into cos square A. Cos square B and cos square A can be changed in the form of sin. So we can write it as sin square A into 1 minus sin square B, and cos square A can be written as 1 minus sin square A. This is divided by cos square A into cos square B. This is because of the trigonometric identity, which is equal to sin square theta plus cos square theta is equal to 1. Now we will multiply and open the brackets. So this will become sin square A minus sin square A into sin square B minus sin square B plus sin square A into sin square B, which is divided by cos square A into cos square B, minus sin square A into sin square B plus sin square A into sin square B will get cancelled out now. So this will give us sin square A minus sin square B divided by cos square A into cos square B, and this is equal to the right hand side and hence proved. Let's now begin with question number 34. The left hand side is equal to sin A minus 2 sin cube A divided by 2 cos cube A minus cos A. In the numerator, we can take sin A as common. So this will give us 1 minus 2 sin square A in the bracket. And in the denominator, we will take cos A as common. So we will get 2 cos square A minus 1 in the bracket. Now sin A divided by cos A can be written as tan A. 1 minus 2 sin square A can be written as 1 minus sin square A minus sin square A, and the denominator can be written as cos square A minus 1 plus cos square A. Now 1 minus sin square A in the numerator is equal to cos square A and cos square A minus 1 is equal to minus sin square A. So the denominator will become cos square A minus sin square A. This is by the trigonometric identity that sin square theta plus cos square theta is equal to 1. Therefore, 1 minus sin square A will be equal to cos square A, and minus 1 plus cos square A will give us minus sin square A. So the bracket here will get cancelled out and we are left with 10A, and this is equal to the right hand side and hence proved. Now let's begin with question number 35. The right hand side of this question is given as cosec A minus cot A. Now cosec A can be written as 1 upon sin A, and cot A can be written as cos A divided by sin A. This is because cosec A is equal to 1 upon sin A and cot A is equal to cos A divided by sin A. Now we will take the LCM. This will become 1 minus cos A divided by sin A. Now the numerator and denominator both will be multiplied with 1 plus cos A. So the numerator will become 1 minus cos square a, since a minus b into a plus b is equal to a square minus b square, and the denominator will be sin a into 1 plus cos a. Now we know from the trigonometric identity that 1 minus cos square a is equal to sin square a, since sin square theta plus cos square theta is equal to 1. So 1 minus cos square theta will be equal to sin square theta. Here sin A will get cancelled out, and we are left with sin A divided by 1 plus cos A, which is equal to the left hand side, and hence we have proved that the right hand side is equal to the left hand side. Let's now solve the question number 36. The LHS here is given as cos A divided by 1 minus sin A. Now we will multiply both the numerator and denominator by 1 plus sin A. The numerator will become cos A into 1 plus sin A, and the denominator will become 1 minus sin square A, because 1 minus sin A into 1 plus sin A is equal to 1 minus sin square A by the formula A plus B into A minus B is equal to A square minus B square. The numerator will remain as it is for now, and the denominator now will become cos square A. This is by the identity, since sin square theta plus cos square theta is equal to 1, therefore 1 minus sin square theta is equal to cos square theta. We will cancel out cos A, so we are left with 1 plus sin A divided by cos A. Now we will write it as 1 divided by cos A plus sin A divided by cos A. 1 by cos A is equal to sec A, and sin A by cos A is equal to tan A. This is by the relation that 1 by cos A is equal to sec A, and sin A divided by cos A is equal to tan A. The answer that we have received here is equal to the RHS, and hence this is proved. Let's now begin with question number 37. The left hand side here is given as sin A into tan A divided by 1 minus cos A. Now sin A into tan A can be written as sin A into sin A divided by cos A, since sin A divided by cos A is equal to tan A. Now the numerator will become sin square A divided by cos A into 1 minus cos A. Now sin square A can be further written as 1 minus cos square A This is by the identity that sin square theta plus cos square theta is equal to 1. Therefore, sin square theta is equal to 1 minus cos square theta. Now 1 minus cos square A is of the form A square minus B square. So it can be written as 1 minus cos A into 1 plus cos A divided by cos A into 1 minus cos A. This is by the formula A square minus B square is equal to A plus B into A minus B. 1 minus cos A, 1 minus cos A will get cancelled out. Now we can write what's remaining as 1 divided by cos A plus cos A divided by cos A. 1 divided by cos A will become sec A, and this is plus 1, which is equal to the RHS, and hence we have proved. The left hand side of question number 38 is equal to 1 plus cot A minus cosec A into 1 plus tan A plus sec A. Now we will convert all the terms here in the form of sine and cos. So 1 plus cot A can be written as 1 plus cos A divided by sine A. Cosec A can be written as 1 upon sine A. Tan A can be written as sine A upon cos A. And sec A can be written as 1 upon cos A. This is by the following trigonometric relations, that cot A is equal to cos A upon sine A, cosec A is equal to 1 upon sine A, tan A is equal to sine A upon cos A, and sec A is equal to 1 upon cos A. Now we will take the LCM in both the brackets. So it would be sine A, and the numerator will be sine A plus cos A minus 1. The second bracket will have the denominator as cos A, and the numerator will be cos A plus sine A plus 1. Now we will multiply both these brackets. The denominator will become sine A into cos A, and the numerator here is of the form A plus B into A minus B, where A is equal to sine A plus cos A and B is equal to 1. So this would become sine A plus cos A whole square minus 1 square. Now we will apply the formula here. This will become sine square A plus cos square A plus 2 sine A cos A minus 1, and this is divided by sine A into cos A. Here we have applied the formula of A plus B whole square is equal to A square plus B square plus 2AB. Now we know that sine square A plus cos square A is equal to 1 by the trigonometric identity. So this will become 1 plus 2 sine A cos A minus 1 divided by sine A cos A. 1 minus 1 will get cancelled out. We are left with 2 sine A cos A divided by sine A cos A. Sine A cos A will get cancelled out with sine A cos A, and we are just left with number 2, which is equal to the right hand side, and hence we have proved. The left hand side of question number 39 is equal to square root of 1 plus sine A in divided by 1 minus sine A. Here we will multiply both the numerator and denominator by 1 plus sine A in the under root form. Now the numerator will become 1 plus sine A whole square, and the denominator is of the form A minus B into A plus B, which will give us the answer as A square minus B square, and that is equal to 1 minus sine square A. Now 1 minus sine square A can be written as cos square A, as sine square theta plus cos square theta is equal to 1. Therefore 1 minus sine square theta is equal to cos square theta, and the numerator will be written as it is for now. Now we can find out the square root of the terms that we have got over here. The square root of 1 plus sine A whole square is equal to 1 plus sine A, and the square root of the denominator, that is cos square A, is equal to cos A. Now we can write it as 1 divided by cos A plus sine A divided by cos A. 1 divided by cos A can be written as sec A, and sine A divided by cos A is equal to tan A. This is equal to the right hand side, and hence we have proved. The next question is question number 40. The LHS given here is square root of 1 minus cos A divided by 1 plus cos A. Now we will multiply both the numerator and denominator by square root of 1 minus cos A. Now the numerator here will become 1 minus cos A whole square, and the denominator here will become 1 minus cos square A. As 1 plus cos A into 1 minus cos A is equal to 1 minus cos square A, by the formula of A plus B into A minus B is equal to A square minus B square. Now square root of 1 minus cos A whole square is 1 minus cos A, and 1 minus cos square A can be written as sine square A, and square root of sine square A is equal to sine A. Now this is by the identity that sine square theta plus cos square theta is equal to 1. Therefore 1 minus cos square theta can be written as sine square theta, and the square root of sine square theta is equal to sine theta. Now we can write it as 1 divided by sine A minus cos A divided by sine A. Left hand side will become cosec A, and right hand side here will become cot A. This is by the relation that 1 by sine A is equal to cosec A, and cos A divided by sine A is equal to cot A. Now this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. So the left hand side of question number 41 is square root of 1 minus cos A divided by 1 plus cos A. Here we will multiply both the numerators and denominator by 1 plus cos A, because we need 1 plus cos A in the denominator. So the numerator will become 1 minus cos square A, and the denominator will become 1 plus cos A whole square. This is because A plus B into A minus B is equal to A square minus B square, and A plus B into A plus B is equal to A plus B whole square. Now 1 minus cos square A can be written as sine square A, and 1 plus cos A will be written as it is for now. This is by the trigonometric identity that sine square theta plus cos square theta is equal to 1. Therefore 1 minus cos square theta will be equal to sine square theta. Now we can find out the square root of both the numerator and denominator. So it will be sine A divided by 1 plus cos A, and which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with the question number 42. The left hand side is equal to square root of 1 minus sine A divided by 1 plus sine A. Now we will multiply both the numerator and denominator here with square root of 1 plus sine A, because we need a 1 plus sine A in the denominator. So the numerator would become 1 minus sine square A, and the denominator will become 1 plus sine A whole square. We have applied the formula A minus B into A plus B is equal to A square minus B square in the numerator, and A plus B into A plus B is equal to A plus B whole square in the denominator. So now the numerator will become cos square A, and the denominator will remain as it is for now. This is because sine square theta plus cos square theta is equal to 1. Therefore 1 minus sine square theta is equal to cos square theta. Now we can find the square root of both the numerator and denominator. So it would be cos A divided by 1 plus sine A, which is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. In the question number 43, 3, the left hand side is equal to 1 minus cos square a divided by 1 plus sin a. Now we will take the LCM here, so it will become 1 plus sin a. The numerator 1 will turn into 1 plus sin a and minus cos square a. Now we will write minus cos square a as minus 1 minus sin square a. This is because sin square theta plus cos square theta is equal to 1. Therefore, cos square theta can be written as 1 minus sin square theta. Now we will open the brackets. 1 and minus 1 will get cancelled out, and we are left with sin a plus sin square a. So we will take out sin a as common. So we will have 1 plus sin a in the bracket, which is divided by 1 plus sin a. Now both the brackets will get cancelled out, and we are left with sin a, which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with question number 44. The left hand side is given as 1 upon sin a plus cos a plus 1 upon sin a minus cos a. Now we will take the LCM here. So it would be sin square a minus cos square a. As we are applying the formula of a plus b into a minus b is equal to a square minus b square, the numerator will become sin a minus cos a plus sin a plus cos a. Minus cos a plus cos a will get cancelled out. We are left with 2 sin a in the numerator, and the denominator will now become sin square a minus cos square a Now sin square a minus cos square a can be written as 1 minus cos square a minus cos square a. This is because sin square theta plus cos square theta is equal to 1. Therefore, sin square theta is equal to 1 minus cos square theta, and the numerator will remain 2 sin a. Now open the brackets. It will give us 2 sin a divided by 1 minus 2 cos square a, and which is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. The left hand side of question number 45 is sin a plus cos a divided by sin a minus cos a plus sin a minus cos a divided by sin a plus cos a. Now we will find the LCM here. So the denominator will become sin square a minus cos square a by the formula that a minus b into a plus b is equal to a square minus b square. The numerator will become sin a plus cos a whole square, as a plus b into a plus b is equal to a plus b whole square, and this numerator will become sin a minus cos a whole square. This is by the formula that a minus b into a minus b is equal to a minus b whole square. Now we will expand both the formulae, so it will give us sin square a plus cos square a plus 2 sin a cos a plus sin square a plus cos square a minus 2 sin a into cos a. This is by the formula that a plus b whole square is equal to a square plus b square plus 2ab, and a minus b whole square is a square plus b square minus 2ab. Now plus 2 sin a minus 2 sin a cos a will get cancelled out here, and this will become 2 because sine square a plus cos square a is equal to 1 and this sine square a plus cos square a is equal to 1. So 1 plus 1 will give us 2 and 2 divided by sine square a minus cos square a are the terms now. Now we will try to remove the cos square a in the denominator because we want 1 over here. So this can be written as sine square a minus 1 minus sine square a in place of cos square a because sine square theta plus cos square theta is equal to 1. Therefore, 1 minus sine square theta is equal to cos square theta. Now this can be written as 2 sine square a minus 1 plus sine square a, which can be further written as 2 sine square a minus 1, which is equal to RHS, and hence we have proved that the left hand side is equal to the right hand side. Let's now solve the question number 46. The left hand side here is given as cot a plus cosec a minus 1 divided by cot a minus cosec a plus 1. Now, in place of 1 in the numerator, we can write it as cosec square a minus cot square a. This is by the identity that 1 plus cot square a is equal to cosec square a. Therefore, cosec square a minus cot square a will be equal to 1. Now this becomes our first bracket. Now cosec square a minus cot square a can be further written as cosec a plus cot a into cosec a minus cot a. This is by using the formula that a square minus b square is a plus b into a minus b. Now the numerator will become cot a plus cosec a can be taken out as common from the left hand side and the right hand side terms. So the bracket will have 1 minus cosec a minus cot a. The minus sign here would change since there was already a minus sign outside the bracket, and the denominator will become cot a minus cosec a plus 1. If we will rearrange the denominator, it is equal to 1 minus cosec a plus cot a, and hence this will get cancelled out and we are left with cot a plus cosec a. Cot a can be now written as cos a divided by sin a plus cosec a can be written as 1 upon sin a. This is because of the trigonometric relation that cot a is equal to cos a divided by sin a, and cosec a is equal to 1 upon sin a. Now we will take sin a as common. So this will become cos a plus 1, and which can be rearranged to write 1 plus cos a, and hence this is equal to the RHS, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with question number 47. The left hand side is given as sin theta into tan theta divided by 1 minus cos theta. Here we will multiply both the numerator and denominator by 1 plus cos theta. So the numerator will become sin theta into tan theta into 1 plus cos theta, and the denominator is of the form a minus b into a plus b. So that would become 1 minus cos square theta by the formula of a plus b into a minus b is equal to a square minus b square. Now tan theta here can be written as sin theta upon cos theta into 1 plus cos theta divided by 1 minus cos square theta can be written as sin square theta by the trigonometric identity, since sin square theta plus cos square theta is equal to 1. Therefore, 1 minus cos square theta is equal to sin square theta. Now, the numerator will become sin square theta into 1 plus cos theta divided by cos theta into sin square theta. Sin square theta will get cancelled out and we are left with 1 plus cos theta divided by cos theta, which now can be written as 1 divided by cos theta plus cos theta divided by cos theta, which is equal to 1. 1 divided by cos theta is equal to sec theta, and this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side. Let's now begin with question number 48. The left hand side here is given as cos theta into cot theta divided by 1 plus sin theta. Here we will multiply both the numerator and denominator by 1 minus sin theta. So the numerator now will become cos theta into cot theta into 1 minus sin theta, which is divided by 1 minus sin square theta. This is because 1 plus sin theta into 1 minus sin theta will give us 1 minus sin square theta by the formula of a plus b into a minus b is equal to a square minus b square. Now cot theta here can be written as cos theta upon sin theta, and by the trigonometric identity we know that 1 minus sin square theta can be written as cos square theta. This is because sin square theta plus cos square theta is equal to 1. Therefore, 1 minus sin square theta is equal to cos square theta. Now, this can be further rearranged as cos theta into cos theta will give us cos square theta, then which is multiplied with 1 minus sin theta. This sin theta now would move in the denominator. So, this is sin theta into cos square theta. Cos square theta and cos square theta will get cancelled out. We are left with 1 minus sin theta divided by sin theta. This now further can be written as 1 divided by sin theta minus sin theta upon sin theta. 1 divided by sin theta is equal to cosec theta, and this is equal to 1. This is because 1 divided by sin theta is equal to cosec theta by the relation of trigonometry. So this is equal to the right hand side, and hence we have proved that the left hand side is equal to the right hand side.